Okay, so here we have an example of a question they're giving us. They say, consider the region R bounded by the parabola y equals 36 minus x squared and the x-axis. To find the volume of the solid when R is revolved around the x-axis, use the method of dis, evaluate the integral. Okay, so the first thing I'm going to do with this thing is I'm going to graph it. So step one, I'm going to graph y equals 36 minus x squared on the Desmos graphing program, right? You have that link on the home page of our Canvas course. So here it is. I've already done it. So I typed in y equals 36 minus x squared. I kind of zoomed in until I could see everything. If you click on these dots, I forgot to click, you'll find that's the point over 6 up there. Just click on them. It'll tell you the coordinates. And this is the point over 0 up 36. Okay, so now we've got an idea of what we're looking at. So we're going to take that and region, and really we're just talking about this region because we're going to, it's above the x-axis, right? If you go back there, and the x-axis. And we're going to rotate it around the x-axis. So we're going to revolve it. This is the x-axis, as you know. We're going to revolve it like that. So what's going to happen is this part's going to come down here. I'm not drawing it too perfectly. In fact, that's far from perfect. But just pretend with me. It's going to basically come down there. It's going to go off the screen. And we're gonna have more of it down here. We're going to rotate it, get a three-dimensional shape. Let me show you real quick the three-dimensional shape. So to do that, you can go to here, let me share my screen. There we go. You can go to the CalcPlot 3D. This also is on the home page of our Canvas course. So I'm at Calc, so just click on the CalcPlot 3D. Here it is. Get rid of that initial thing they show. You go down to surface of revolution. They have a function already in there. We want to put in y equals, what was it? 36 minus x squared. Okay. And the bottom, that's the top, and the bottom is y equals 0, right? Because that was the x-axis. Hit enter. Sometimes I forget to do this. You've got to hit enter. Boom, I just hit enter. Okay, so it did it. Now, it doesn't look like much, right? So you got to zoom out. So I'm going to come up here and I'm going to zoom out. Boom, boom. Oh, and also see how x is going between 0 and 1? Remember, we saw that we want x to go between -6 and +6, and then hit enter. Enter's the key. You type it in, it does not hit enter. Boom, there we go. Now we're seeing the problem. Let's zoom. I'm gonna hit zoom out a little bit more. Zoom out, maybe one more time. Zoom out. There we go. There's our graph. So there's our parabola. You can see it over here on the 3D image. Okay, so now we want to, so you see what I had to do there? I had to go between, how did I know between -6 and +6? Because I saw that on the 2D Desmos grapher. That's why I do both programs. It's just helpful. So I start with the Desmos 2D grapher. I could click on it. I could clearly see the graph goes on the x-axis from -6 to +6. And and then I put in the function, and then I just zoom out, zoom out. But you got to hit enter whenever you put something in down here, and then it does it. Okay, now we want to revolve this. Oh, and we're revolving about y equals 0. Is that right? Well, it said about the x-axis. So that is y equals 0. So yep, that's right. Here we go. And there is our three-dimensional shape. And you can move it around and see it. That's the shape, that disk we're creating. Now, I got it kind of off a little bit here. It's a little hard to control this thing. Okay, so now what we want to do, there we go, it's a little better like the Y, except it's sideways. All right, so now I'm going to come down here and I'm going to undo it a little bit. I can do that. There's the Y, and I'm kind of cockeyed though, huh? Okay, there we go. And now I'm going to come down here. I'm going to click on show the washers. Boom, there's the wash. I have it set to 4 washers. You can do more washers or less washers. It's just showing 4 or 5. I'll do 5, 6. I guess that is 6 washers. Okay. And then I can actually rotate those washers. Here we go. See, that is right here. Revolve the washer shells. So there are, in this case, the washers. They're discs, really. There's the discs. we're going to fill up that three-dimensional shape with those disks. So we're going to calculate the volume of each of those disks, and then as n goes to infinity, as the number of disks goes to infinity, the disk gets smaller and smaller and smaller, and we get closer and closer and closer to the actual volume. And by the way, it gives you a volume estimate. See down here, 26057. That's probably close. You can't exactly rely upon it. It's not perfect, but it's close. So I'm going to go back to only like 5 disks, and I'm going to unwrap it a little bit so we can see them. So there's the disk. So we're trying to fill up that shape with disks. You can go back and you see the original graph. So there's the actual shape, rotated around the x-axis at least part way. And we want to fill it up like that. Not only that, by the way, and you can also see the rectangle. Let me unwrap it with this little program. You can go click, and it puts in that little, see that little rectangle? See the 3D shape over here? See how that rectangle is moving? That's the rectangle. Then you can rotate that rectangle. That's one of the rectangles, right? That we're revolving around as a disk. Anyway, good enough. We're seeing the 3D things. Let's go back to actually solve this thing now. So let me go back to my iPad. Oops. There we go. Okay. And share that with you. Okay. So back to the problem. So we saw the 3D, we saw what it's looking like. So now what's helpful is to have this little formula sheet. So let me put that in for you. Is it this one? Yeah, dishwasher. There we go. So there's what we need. There's the notes. So that's on the home page of our Canvas course. Click on notes. You can get this dishwasher method notes. Okay. So what did ours look like? Remember the picture? It looked like this, didn't it? Right? We're gonna do one like this, and you can tell because they said dx. They kind of gave it away. They said dx. So you're saying, all right, so I must be this dx, not this dy, not this one. In fact, this is what our thing. See that little rectangle? This is what it looked like. Remember, the rectangle was vertical, and we're rotating about this x-axis. That's the other thing you can tell. It says right here, dishwasher rotated about the x-axis, right? Ours said rotated about the x-axis. I'm giving you the different ways you can tell that this is the formula we're going to actually use right there. Okay, so let's bring that up. Let me, in fact, just put that right here for us where we can see it a little bit better. That's not what I wanted to do. There we go. Let me crop it so we can see it nicely. And there we go. So I'll just put it right. Put it right here for us. Crop this left side a little bit. Okay. And there we go. So I'm going to follow that formula. So here we go. It says the volume is the integral with a pi in the front. Pi, the integral from left to right. I'm just going right here of capital R squared minus little r squared dx. Okay. So it's going to be pi. What's the left and the right? Well, if we go back to here, we're going from left to right. So from -6 to +6 of capital, and what's R? You can see right here, R is all the way up, right? See that little display? So what is that? Do we know what that is? Yeah, so that R is, so I'll put some random, we're integrating, I'll just put some disk in right here. Right, this is one of our disks. So there's one of our disks. Um, so this our R then is all the way up there, our capital R, which is what? That's the Y value up to the function. What is this function? This is the function Y is 36 minus x squared. Whenever you go from the axis up to a point on the graph, that's the Y value, which is 36 minus x squared. So the capital R is 36 minus x squared squared. And what's the little r? We don't have a little r. Little r is if you have a gap here, ours goes all the way down to 0. We have no little r. right? This is just generally telling you if you have a washer or you have a gap, a hole in the middle. We don't have a washer, we have a disk, we have no little r. Ours goes all the way down to the axis. So our little r is 0. So that's all we're going to do, dx. Now, to get the answer to this integral, we don't have to do it by hand. We're just going to type it into the Desmos grapher. So back to the Desmos grapher. Um, I'm going to type that in. Let me show you that. So I'm going to switch back to the Desmos grapher. Let me see, stop sharing that and share again my main screen. And I'll go to the Desmos grapher. Here, let me clear out all these things I was doing. Y equals 36 minus x. So let's put that in again anyway. So there's that. But now I'm going to do an integral. Now, how do you do an integral? You type in I N T. You tracking with me? INT. So I just typed in. In fact, let me just show it. Um, right. Yeah. So I typed in INT, and we're going to integrate from, remember it was -6 to +6. I'm going to go to the left and put in, what was it, a pi. Just type pi for pi, or use their little thing down here, and you can just type a pi. Now I'm going to go to the right and put in the function, which was 36. I'll put parentheses, and it was 36 minus x squared. And then the whole thing was squared, right? Because it was capital R, which was 36 minus x squared, squared. Capital R squared, and then dx. Boom, it pops up a number, 26,057. 26,057. By the way, back to our calc plot 3D. Remember when let me get rid of the rectangles. When I showed the washers, see, that was pretty close. 26,000. Now it's not exactly right. If I do more, it might get closer. No, it's best to do 26,057. The Desmos is given us the real answer, which is 26,057. What's that saying? Oh, yeah, that's pretty close. But the decimals are wrong. 6297. The decimals are 6261. Pretty darn close. Pretty darn close. So, so there we go. Now, if you the answer you might have seen on my screen was pi. It was pi 36 minus x squared. Or oh no, I'm sorry. Yeah, I'm getting a little confused. We don't need to give an answer to this one, do we? We just needed to set it up. And so I'm just going above me. So if they ever want you to have an answer, a number, you just type it into the Desmos graphing calculator like that. And so there we go. I hope that was helpful.